Today, I am going to take a step back and leave it to Shashank. And Shashank is a student here at the Data Lab, and he knows way more data engineering than anyone else out here, and that's why he's giving the lecture. And today is going to be about what databases are and how to deal with them. So without further ado, I would like to give Shashank the podium, and please, Shashank, drive.
Okay, so before we start, I just want to know from the participants, like, what do they know about SQL or relational databases, so that I can think of like where to start. Okay, Sarah says yes, yeah.
Jeff says nothing.
SQL, but I've not really used it in practice, so I'm just a basic knowledge of SQL.
Okay, we can start. I'll start sharing. Let me. Okay, so obviously not much either. Okay, good, great. So yeah, the first task is to go to your HPC, log in, and open a Jupyter notebook. And I think, Michele, did you cover this? That once they log in, they can go to this Jupyter notebook and open one.
I believe that it was mentioned that
Yes.
you can open the Jupyter notebook, but why don't you copy and paste this URL and post it in the chat?
Which one? This one?
No, your general URL. So where are we? Open on demand.
Yes.
So I'm just gonna copy this and put it in the chat so people know where we are. Give me a second. Please do go to open on demand.
Yes.
Yeah. There is too many URLs, so sometimes it's easier to copy and paste. And tell us what we have to do, Shashank, once we have logged in.
Yeah, so once you have a Jupyter notebook running, the next task for you is to copy two notebooks which are available in the Data Lab group folder and copy it to your home directory. So what's the best way to do that?
Please be kind with us. Tell us how to do it.
Yeah, okay. How do I launch a Jupyter notebook?
Okay, so once you are logged into your dashboard, you click to your Jupyter notebook, choose a cluster, put some runtime, and so that's my setting for right now. And then since everyone in the DSF is, I think, a member of Data Lab group, so you can just put the PI group as Data Lab and just click on launch here.
If you're able to queue up your Jupyter notebook, do give us a thumb up.
The link you posted didn't work for me, Michele.
Can you repeat?
I came up with when I clicked that link you posted, it went home directory not found.
Ooh, fun.
Is it like open shell?
What about just this?
I think just log on to, yeah, this, yes, exactly.
Yeah. OOD stands for open on demand.hpc.arizona.edu.
So funny, the same thing came up for me.
Ooh.
Home directory not found. What does that mean? I can look into it.
Do you need to be logged into your U of A account first for that link would work? I don't know. That's a question.
Maybe. Yeah.
No, the
login should happen as you click on this link. So you click on the link and then it should ask you to log in. Okay, hold on.
Yeah.
Obviously it starts like this.
Shashank,
Yeah.
how did you get to the page that you're currently on?
Yeah, it's the link which Michele posted. It's od.hpc.arizona.edu, and then you
Yeah, I'm
yeah,
on the I've clicked on that and I'm logged in,
yeah,
but
and then you click on like interactive sessions, like this tab here. It will show you like what tab you have. So right now I am running like 2 interactive desktops and 2 notebooks.
oh,
Yeah.
okay. Then after clicking and interact,
Yeah, and then you can click on like connect to Jupyter here. So once you click, it will open this thing. This runs in your home directory.
okay. Do I need to change anything in the requirements like the RAM and the GPU and all that?
No, you don't need a GPU. I think it is very straightforward. Just for the group name, you can put any group name, either your lab name or just put data lab, I guess, if you're part of data lab. I'm just assuming everyone in DSF is in the group of data lab.
Yes, everybody is
Yeah.
in data lab. Okay, Mary, do you know how to open an incognito window? Try to open the link in an incognito window. This may be due to cookies and caches. Still can't get there. So Sarah, are you not able to log in?
I'm on something that looks like that, but I don't see the notebooks. I am being asked to open like a new notebook and it won't launch.
Okay, Shashank, can you unshare and let Sarah
Sure.
share?
Yeah.
Would that be okay with you to share, Sarah?
I think so.
Okay, hold
So
on.
this is
Yeah.
where I get, and then
Okay. Yes.
I chose Ocelot.
Oh
And
yeah, so
PI
in
group,
PI
yes.
group, you need to add data lab.
Where?
PI group, the fifth,
Second last, I think.
Yep. And there you have to put data lab all together.
Without a
No
space.
space.
Yeah.
Sorry. Yep. There you go. Okay, now you're queued. Cool. Sarah is on board. How is Mary doing?
Same message. Home directory not found. That's so interesting. Who knows? But I can keep trying, but we can move on. Sorry.
And I have to interrupt again. I am still not where I was supposed to be. I'm now, I guess, in a directory. It's doesn't look the same. Do you want me to share my screen again?
Yeah, sure, you can share. I think Mikhail is muted, so we can't hear him.
Yeah, I'm not saying anything. I'm just
Okay.
waiting for the share to happen.
Okay, yeah.
Cool.
Oh.
So now go to, everybody else can do this as well. On the left, you see /groups. Click on the /groups. Cool. And now scroll down to Causey.
Yeah, Control F would also do, yeah.
There we go.
Yes. Yeah, here.
And you can highlight you can select the FOSS plus part 1 and part 2. And I believe you can copy these. Do you see on the top right, you see copy move above? Yes, copy move. And then you want to copy them on the left to your, whoa. We can do this. Click OK and click home directory below copy. And then click copy.
Yes, yeah.
We did it. We're doing it.
Yes,
Okay, fantastic.
yes, great.
If you're able to get here, please leave a thumb up. I think we'll give you a couple of minutes.
Okay, but what do I
Right.
do now?
Right. So, okay. So right now, that means that you have copied your files onto your own home directory. And what you want to access now is the apps. So if you go to the top, yeah, I think if you click on apps and click all apps, maybe it shows you, I want to see the running apps. So jobs,
It's
sorry.
it's an interactive session.
It's an interactive sessions. Oh, yes,
Yes.
yes.
Yeah.
The interactive sessions. On the top, middle screen. To the middle. Where it says my interactive sessions on the top middle. You're so close. To the
I
right,
don't-
to the right, to the right, to the right. To the right, you're going left.
that one.
There you go. There you
Yes.
go.
This
Yeah.
the gray is terrible. It looks like it's defaulted. All right. So, oh, this is
All
where
right.
I'm supposed to be.
Yes.
Okay.
So the thing is, you have run it, and you have copied the files. So you need two things. You need to have a running Jupyter app, and you need to have copied the files onto your home folder.
What files? How did you copy the file?
We just showed it, Jeff.
I don't know how to get there.
Okay, I have to do it too, so I'm going to show you again how to do it. This is just because Jeff is asking me.
Okay.
All right.
I have no idea what you just said.
I
launched the Jupyter, but this copy the file thing, I don't.
I got you, Jeff. You're fine. I'm gonna come in and save you. All right. You may see this. Okay, this is your open on demand dashboard. You go to files, and you can, for example, click home directory, groups, or Xdisk. Okay, Jeff?
Yeah.
Click groups. Now, the groups directory is going to open, and you want to scroll down or Control F until you see COSI. Okay?
Yep.
You click on COSI, and you're going to find FOSS plus part 1 and FOSS plus part 2. You select these two, go over here where there is copy and move. You're going to click on that copy and move, and you're going to go to home directory, where you click home directory and then press copy. Bam! Now it says 100% copy files. You scroll down to see what's up, and your files are right here. Are you good, Jeff?
Yeah.
Cool. Now on the top, you can go to my interactive sessions. And here is your Jupyter notebook, which you can then click to connect. I did notice, Sarah, by the way, that your notebook is going to run for the next 50 minutes. So you might want to launch another one that asks for at least 2 hours instead of just 50 minutes, since this is going to run for a while.
I don't really know how to do that. So we'll just
Hold on, why are we
play
using
it
HPC?
fast and loose.
Okay. Yeah, okay. So if you want to know, if you want to do that again, you go to interactive apps, click on Jupyter Notebook, and when it says runtime, you select 2 hours. So my specs are 2 hours, 4 cores, 8 mem per core, no GPU, data lab, and launch. gonna make this a little bit smaller. And Jeff, we are using the HPC because we've been working on the HPC for the past 3 weeks. So that's why we're using the HPC. I got on the HPC, but mine is queued.
I meant my Jupyter notebook.
Oh,
My
okay.
Jupyter notebook is queued.
That's good because it's in the queue. That means that eventually it's going to start. Good that you are on board. Were you able to do the whole file copying thing? Cool, fantastic. I'm gonna give it back to Shashank. Sorry for taking over, Shashank.
It's okay. It was helpful. Okay, so yeah, we can start. And yeah, so if your Jupyter notebook is running, if you click here, let's say connect to Jupyter, it should open this page. And right now you can see many files in my home directory, but you may find less files or more files in your home directory, and you'll find the 2 notebooks which you have copied, and you can just click any one of them. Say, let's start with part 1. And once you click on it, it will open that Jupyter notebook, and then we can start. So if you have reached this stage, just please let me know. Mm. Yeah, one thing I forgot to tell. One sec. Okay, yes. Yeah, so before we even start and see like what is even SQL and DuckDB, we need to do some go through some basics. So yeah, let me give me one sec. Okay, yeah, sure again. Yes, now we are back to our FOSS GitHub Pages website, and now we can start learning databases in DuckDBs. So is everyone good? Can we start? Okay, cool. So what's that? Yeah, so for this tutorial, just follow along till we reach this install DuckDB, and after that we'll move to the Jupyter notebooks. So there's not much in the theory to cover. So let's get started with databases. So databases is a structured collection of data, which means that there are tables. So basically covering relational databases, there are tables which are interconnected. So for example, let's go through this figure. So here we have 4 tables uh, which consist of customers, products, employees, and orders. And in the first table, we have data about customers. So for example, this could be an example of an Amazon, like for example, Amazon, where there are different customers, there's and different attributes attached to them. Like for example, for the first
I believe
there's a
he's
next
frozen.
table.
Okay.
Yeah.
Can you I don't know if it was me, but you froze for me a second. Can you
Post the link in the chat. Okay, sure. Am I audible now?
Yes, yes. Okay, but is it me? I don't think it's me. Okay. Well, hold on a second. I'll post the link in the chat.
Thing is up this big order table where if somebody makes an order, then what? And
You're coming and going, Shashank.
am I audible now?
Yes.
Yeah. So if it happens again, just let me know. Right. Because I don't see here that I'm stuck. So because for me it just says. Okay, so all these three tables are linked to a bigger table which has the information about orders, and what we can see is that all these four tables share some kind of information, such that this order table has information on the orders containing the different keys such as customer ID, but this customer ID links the orders table to the customers table using customer ID. So this is an example of a secondary key where, so for customers you have this primary key customer ID, but this ID is present in orders, which links to customers and orders, these two tables. Same goes for products. So now you have, since let's say some customer has some order placed for a product, so that will go into the orders table where it will have, okay, which product ID this customer bought. So this is an example of a relational database where different tables are connected to each other. So similarly, today we would be looking at one example of a healthcare system where there are like several tables, and each table is, some of the tables are linked to each other. And yeah, next is SQL. So what's SQL is a simple query language, which means that using SQL, you can do different operations, such as given a database, you can read information from the database, or let's say if you want to set up your own database, you can even do that using SQLs. And there are two types of SQL statements. We'll look both of them today. The first one is data definition language. So this people use to set up database, such as create, alter, and drop. We'll look some example of these today, which means that these data DDL, these data definition language statements are uh, catered towards manipulating the tables itself, but not the data inside them. So for example, using create would create a database or a table, alter would change those tables, and drop means that either you can drop, or drop means delete. So either you can drop that table or drop that database. Yeah, DML statements are data manipulation. For example, this is basically the major part of today's exercise, that using the select, insert, update, and delete command, instead of working on the tables, we focus on the data inside the tables. Let's say you want to change or update some of the information in the tables, so then you can do that using DML. Okay, now coming to DuckDB. Before we go to DuckDB, there are multiple SQL databases you may have heard of, like MySQL or PostgreSQL, but DuckDB is another software, you can say, for using SQL, and it's good because it runs in memory, so that you don't need to set up any fancy things, like just using a pip install DuckDB. You should be able to use DuckDB and connect it with your data. And the one more good thing about DuckDB is that it can connect to, let's say, pandas, or if you have a huge data size, then it can link to Apache Spark. So it can integrate with different tools easily. That's why it's a good starter database to look at. Yeah, so now since am I stuck again? Okay. Okay, so before we go to the code, so now this code is starting. So this is the same code which we have in our Jupyter notebook. So we can go back to Jupyter notebook and start running things from there. Okay, any questions till now? We go over and like as I said, using DuckDB is very easy. Just need to have a Python environment, and you can just do like pip install DuckDB, and I suppose this should work.
So you're just running the first cell now, right?
Yes, yeah, I think
Okay.
it's stuck. I don't know what's happening.
It's running for me.
Okay, maybe this is the current redundancy. Yeah, I think. Why do I have to Jupyter notebooks open? Okay, we are back here, and then yeah, maybe we can go to the next cell and import DuckDB. No, it's stuck. Yes, yeah, it's working now. Yeah, so for this tutorial and for my other tutorials in the data lab for data engineering, I work on this COVID-19 patients dataset, which has 100K synthetic records. And I provided this on U of a box. So if you run the next cell, it should be available in your home directory.
Hey, Shashank, I don't think anyone's able to import DuckDB into their Python environment.
Okay, so the first one was pip install. I think this should work.
Right, that appears to work, but then import, it's like, what module? There's no module called DuckDB.
Oops. Hmm. Files.
Maybe it says we may need to restart the kernel to use the updated packages.
For me, it says it's installed, and then yeah.
I confirm what Jess said, which is you need to restart the kernel after you install DuckDB.
Yes, that did it.
Okay.
Yeah, so show people how they can restart the kernel.
Yeah. So the kernel restart is here. If you okay, zoom in this button here, it says restart, and let's restart. And then once go for DuckDB should work. Yeah, please let me know if you restarted the kernel and this import DuckDB command worked. Okay, if it works, then you can go to the next cell and run this wget command, which will download the data provided on the Arizona box. And so basically all of this data, okay. All of this data is available in a file called which ends with .duckdb, and once you download it, it would show in your home and it should say this by this name, my database.duckdb. Yeah. Is it working, guys? Please let me know.
The download worked for me. Okay, you're just checking for the download, right?
Yeah.
Okay.
Yeah, so before we start, we need to have this my database.duckdb in our home folder where the notebooks are, so that we can import this folder and then connect to it.
Just letting you know, the name of the database is different than the name of the file I downloaded. So I have to go ahead and rename it.
Yeah, my underscore database.duckdb is not quite right. It's more like my database dot, it's my underscore data. Well, let's see. That's odd. My underscore database dot duckdb, my underscore database dot duckdb. The file name is something's wrong.
Okay, so I can tell you how to rename it. If you click the database here and say rename, and it should open this box, and then you can just put my database or any name you want to have, name the database. Did it work? Yes. Yeah, please let me know if this worked and you were able to download the database. And then we can move forward. Okay. Yeah, so once you have downloaded the database, you can connect to it using this. I can just zoom in here and you can connect to the database using the command which says, since we have imported the Python library and the name is here duckdb, you can use this function dot connect, and in the database argument put the database name here. And since it's already there in the notebooks, what you can just do is like let's run. So now this command creates a connection of your Jupyter notebook to the .duckdb file which you've just downloaded, and before running any queries or looking into what data we have, you can just first look at what tables are available inside the database. So for that, And for all of our next commands, the structure looks like, so we will use this connection we just created and say that, okay, we would like to run a SQL. This SQL means running the SQL on this connection, CONN. So, and then whatever goes inside the parentheses is basically exactly similar to what people use and do, like running other SQL application, let's, for example, like MySQL. To run this, run you the tables inside, and based on the rows, you say, okay, this database which you have just downloaded has 16 rows inside it. And we are just looking at the three tables for extracting some information. So before we write any query, we should, let's say if we want to focus on the patients table and see what kind of patients are there, what attributes are attached to those patients. So for that, before like running any query, we need to know the column names of particular tables. So similarly, what you can do is use the connection, say, okay, you want to run the SQL, which goes into the parentheses and want to run this on this connection, you should say describe patients. So what this will do is it will look at the patient's table and describe what it means, that it will look at all the columns and look at what character types are there in the column. Like, for example, are they a number? So in SQL, text is showed as this varchar, which is like variable character, and numbers are shown as double, which is a data type. So these two are data types in SQL. Okay, and null means that this can have null values like non the what you have in NumPy is like .nan. Okay, and then the next is uh, uh, like key, default, and extra. So we don't need to go into this right now here. So we'll just focus on the first three columns: column name, column type, and null. Okay, so once you run this describe patient, it should say that there are 25 rows, but it's just showing us 20. And there are 25 columns inside this patient's table, although we are seeing it is in the rows based on the result of this command. Did it work for everyone? Okay. Okay. Yeah, another example is looking at the same command describe, but for another table. So basically, before running any queries, we just would like to know that, okay, if we want to work with, let's say, patients, medications, and immunization, these three tables, then what are the different column names, so that we, before running queries, we have some idea that what queries we want to write. Okay, so now we can look at the medications table, and it shows, okay, there are 13 rows and different columns, which are like when did the medication start, on which patient these medications are given, what's the code, what's the description, like what these medications are about, what's the cost of these medications, and so on and so forth. Okay, and yeah, next should be, yeah, querying data. So this is the most common operations which people do on databases, that given a database, you're not editing it, just trying to extract information for your own use. And for that, you can use the select statement, which can be, as the name suggests, you can select the data from a database. So, and before you write the queries, you should form the question. Like, for example, a question could be that query the patient's table and display these 4 attributes. So this might be the first SQL command for many of you. So let's understand it. So we are still using the same connection function here, variable here, which is connecting the notebook to the DuckDB file. We are telling it like we are trying to run SQL. And in the parentheses, we have this command, which is exactly similar to the SQL command. And how it works is that we are telling it that select using the select function. We are telling select, and next we are mentioning the column names which we want to extract. So like in the previous command, we looked at the column names. So and from there we got this idea that okay, we can extract first name, last name, and city and gender here. And so once we mentioned that, okay, these four columns we want to extract, then we mentioned, okay, which column you want to extract these from. Now is from, and then mention the table name here. So in summary, what this command is doing, that it's going to the patient's table first, and from that it's extracting these four columns and showing here. So if you run this, it should be, yeah, it should run very quickly, and it should show that, okay, there are like more than 10,000 entries, and we are just, it's just showing us, like for brevity, just showing us 20, and you can see them. If it didn't work for everyone, just can I see a thumbs up? Okay, great. Yeah. Okay, next we can, so initially what we had is that this table didn't give us like the total number of rows here. So like, for example, let's say we want to know that, okay, count the number of rows in patients table, which would give us an idea that how many patients are there in our database. So what you can do is use this the same function, and now instead of uh, mentioning the column names, we are using this function count, and in the function we are mentioning star, that okay, we are not interested in any of the column, we just want to know how many rows are there. If you run this command, it shows it's about 124K patients in the database. Okay, moving on. Okay, since we in the previous command we saw that these patients belong to different cities in the state of Massachusetts, I suppose. So now, let's say we want to know that, okay, how many cities are there in this, because here we can see that there are like different patients who belong to the same city, but we just want to know how many unique cities are there. So for that, we can use this distinct function and then use count over it. So this is one example of writing a nested query in SQL, that we are still querying the patients table here, but the query changes based on the function that we want to know how many distinct cities are there. So if we don't run this count function, it would just gives us a list of all the cities present in the database. But right now we need the count, so we are wrapping up this distinct city over the count function and then selecting it. So if you run that, it should say there should be 351 distinct cities present in the database. Okay. Okay. Next is about this is a query. I think it's like you want to have a distinct on both city and gender from patients. So what we are doing is we are querying the patients table here, and then the attributes we are interested in is city and gender. We are putting a distinct over them. So once we run this, we should say, okay, they are different cities, and then they are different genders, and it may be a possibility that only some genders are present in one city here. So there are total like 700 rows, but assuming that there were 351 cities and each gender lying into one of the cities, so we should expect around 700 results. Okay. Next, we can look at how can we filter data, because initially we were just returning all the columns. So for example, right now, if last time we ran the select column from patient, now let's say we are interested in only those patients who belong to the city of Springfield. So that's where the uh, where function comes in. And for where, what we do is we provide this where condition after the table. So again, we are looking at the patient's table, selecting these four. So before even select it, run filter on the table, tell the, uh, telling the program to say that, okay, from patient's table, wherever you find city as Springfield, filter those rows and then show only the first, the four columns you would like to know about. So for example, the first name, last name, gender, and city, and passport here. So if we run this, it should filter out the data and just say that it just gives us a list of 2,814 patients who belong to the city of Springfield, and the five columns which we were interested in. Okay, next you can have multiple conditions in the city. So what you can do is, if your question is just want to know about female patients in the city Springfield, so you can have a multiple filtering. So using this where, what it's doing is that it's looking to the patient table, and first it filters on the city Springfield, and then on those results it filters on the gender F. And once these two conditions match, it outputs the four columns you were interested in. So it runs, and then you have all the uh, female patients on the city of Springfield and their information there about like 30. Another this example is about nested selection, that instead of just one city, what you can have is like a multiple city example, that now instead of just Springfield, you want to look at city Springfield and Boston. So either they can belong to Springfield or they belong to Boston, and once you wrap them up in this parentheses here and say that you're interested in looking at all the female patients and either they can belong to Springfield or Boston. So this command filters out the data first from the patient's table and then returns the columns of first, last, gender, and city. Yeah. So then we can see that, okay, once we included the city Boston, the number went up from like 1351 to about 700. Yeah, another way to do the same is, so initially what we did is that we said, okay, city in Springfield or city in Boston here. So we were using this or to link both the results from city Springfield or Boston. Another way to do this is the half of the command remains same, but the filter command changes that what you can have is like city in or in Springfield or Boston. So this is useful, let's say, when you are having multiple cities available, so you don't have to write city equals to Boston, or let's say city equals to X, city equals to Y, city equals to Z. What you can do is you can define some variable here, and you can use it here to just say that city, if even if one entry matches in, let's say, for example, let me take, okay, let's say this. Let's say if I want to add something, yeah. So let's say if you want to move more one here, so we can have Somerville here and just run this, and then you will have patients. So now you can see the numbers increased. So if you want to do more selections, you can just keep adding the city names here, and that will filter. And this is like a concise way of writing the previous command, that instead of say city equal to Springfield or city equals to Boston or city equals to something else and so on and so forth, you can just wrap them together in one single parenthesis here.
Hey, Shashank, I have a
Yes.
question for you.
Yes.
So yeah, when you run the another way
Yes.
command, if I run it once, think like it displays differently if I run it multiple times.
Yes, yeah, that's true. Yes. There's no like one correct order in which these entries appear.
Okay, because it's just showing 20 shown out of 7,191.
Yeah, and then the order can change. Yes.
Okay.
Yeah.
Okay.
Yeah, because we are not using any sorting command here, we have examples. So one of the sort, what we can do is sort the first or last so that they appear in some order. Okay, next is example of missing data, because we just saw in one of the previous examples that some of the passport fields were null here. So next we will look at like how can we filter the rows which have null in their passport from this bigger table. Okay, so let's go back here, and now we are trying to look at the first name, last name, gender, city, and passport, but we have an extra filtering step where we are saying select all those patients from city Springfield, but their passport should not be null. So what this gives us, that it gives us like all the results from the city Springfield, but then they have one passport number available with them. Okay. Okay. Same thing goes with null. So instead of is not null, can have like is null here. And then once you run this, we'll say, okay, these all patients, they do not have a passport number here. So in this way, you can like query SQL databases, filter out the non-null values, and probably then export them later for some other use. Let's say if you want to do some visualization or some model training. So that's how you can do it. Okay, next is an example of filtering in numeric range. So initially what we looked at only doing filters on text values wherever the text matches now, but then this example shows how can we filter patients based on numeric values, and that's how you do it. Is like very easy in SQL. It's just, I would say it's just English, that you want to have this column between some values, and then you mention those numbers here, that you want to know what patients in the city Springfield have the healthcare expenses column between 1.5 million to 2 million. And once you have this min and max range, and run this command, it will show you that, okay, these are the this is the list of patients which have their healthcare expenses between the given minimum and maximum range here. Okay, next is the example of limit. So initially what we were looking at, whenever we ran something, it just gives us like a lot of results. But let's say you just want to query the data and see how the data looks like. So you can limit the whatever results we have just, and then put a number here. So it's the first command which we ran there, we didn't have this limit. So if I just like delete this, it will just show you that, okay, there are about 10,000 rows and only 20 are shown. But if we can use this limit here, it will just limit it to the top 20 results, which starts from here, and then next the top 20 results from here. So this, yes, and now we have the top 20 results here. Yeah, I think now this will answer your question, Jeff, that initially you were running it and it was like giving you a different order, but using this order by and then ascending, this will order the results alphabetically. So for example, what I'm doing is So still here, the command remains same. The changes is that now I'm telling a SQL that order this tables based on last name, but how do I order? Is so, and then ASC tells this that use ascending. So put the results in ascending order. So, and then limit comes from our previous command that don't want to print all the results, just limit to top 20 results here. Once we run it, we'll have it like all the patients, and then we are uh, filtering them and then ordering all the entries based on their last name and in ascending order, so that all the Abbotts are appearing together because of their last name starting with an A. Yeah. Yeah. Similarly, we have order and then descending. So instead of the from A to Z, you can have the reverse order. Here, the only difference here is that there are like special characters available in this database. So that's why this special O with some special character on the top appears after the Z. So once you run this, it will show that, okay, all the Oscars are here, which have the which with their name starting with this special character. Yeah, next we are looking at aggregating statistics from this data. So for example, and then we'll use this group by command here. So yeah, the question could be that you want to count patients by city. How many? So because we looked at all the cities, there were 351 cities in this database. So now you want to know the distribution of patients in each city. So what you can have is we it still looks at that patient's table, and then group all the patients together based on the city, and once and then based and that result, what we are doing is we are putting that result inside the count function, and then we are calling this count function as a new name as patient count. So once we run this, and this also gives us like a random order here, and then we can order them just to see. But yeah, so it tells us that there's like different patients are there in different cities. And how do we know this is correct? That what we can do is either like sum them up, and it should match with our 124K number of patients, or see the number of rows here is exactly the same as when we ran the command to see how many cities are there in the database. Yeah, so the next commands tell you that, okay, the counting patient by city and then sorting from highest to lowest. So we have half of the commands same here, but now we have this extra order by coming after group by. So till this part, the command is same. Now we are having additional functionality here, order by, because we have defined this new variable patient count here. So we can order that the resulting data onto this patient count column and in descending order. Once we run this, we'll have the cities appearing in the descending order of the number of patients they have. So probably it's obvious that Boston is a major city, so most of the patients belong to Boston. Yeah, next example is that, okay, we have city and then we have the total number of patient count, but let's say you want to split them up into their gender, that how many male and female are present in then each city. So the command still remains the same, that we have order by on total patient in descending order. We will limit it to only 10 results, but here we will have gender as one extra column. And once we run this, we'll have, so now what this command did is that it just split the count of the total number of patients in Boston and into two parts based on their gender. So you can see, and if you like sum them up, just these numbers. For Boston, it should match with your actual number for all the patients here. Okay, now we can look at another table, which is the observation. We had the same command before, and this table using this describe and then the table name, which is observations. It tells you what different column names are available in this column. And similarly, you can, similar to the patient's table, you can run it once and see. Let me zoom out here. So run it once and see, okay, given some of the column names, we just want to know, okay, how the data looks like. So can run this once and see. Okay, so these are the, so let's go through the column names here. So this patient is an ID, and this patient ID is exactly what you have in the patient's table above. So that's the, so using this ID, so this ID links the patient's table and observations table here. And you have encountered this, what of observation was made and given encounter. So I think this patient has the same encounter, and what observations are made are like, for example, body height or pain severity or body weight, or and let's say blood pressure or heart rate or respiratory rate. So this kind of data set can be used in, let's say, some time series analysis once you reformat this into, let's say, features versus time. Okay, and yeah, so we just have like 5 columns away here because we filtered our data set, and there's like more than 10,000 observations available. Okay, so now what things you can do with the data set is do some summary statistics that, let's say, you want to know the average rate of average heart rate by patient. So we can start from the right, that what, so the first, so the order in which the SQL command works is that first you have to tell, okay, which table you want to work on. So this says, okay, if we want to work on this from observations table, and then you go to the where command to filter the data, which you say, okay, now I'm looking at the observations table, and then the next column I'm looking at description, and this description should look like anything which matches this string heart rate. So we had this heart rate, so this is string, but how do I tell the SQL that, okay, given this data, you want to look at only those columns where this heart rate appears. So that's like a string matching function that you wrap them up in like this %, and say that, okay, you want to look at all the rows where description looks like heart rate. And then once you have the result, group them up based on patients. Yeah, and then how do you group them up? What you do is, yeah, grouping the patients, and then it goes back here that whatever value you find here, uh, put them as a decimal in a double format, because here we see that the value in this table is a variable character. It's not a double, which means that initially it was in string format because it's variable character. So even before we do any mathematical operation, let's say sum or average, we want to convert it to number. So this is a function which takes that, okay, we are telling this that, okay, whatever value you find here, cast that value as a decimal and round it up to like some of the decimal places here, and then round it up again, and then take the average. So EVG means that whatever heart rate was there for each patient, it first convert them into a number, took an average, and then rounded them up, and then put the whole value for this column into and then renamed it as average heart rate. And now this average heart rate will be used by this order by to put them in a descending order. So once you run this, you'll see that, okay, there's like some patients have their average heart is like 200 and then 199. So then why we see 20 results? Because we were limiting these results to 20. So yeah, this looks like a very complex command. So I would like to know if anyone has any questions.
Perhaps not necessarily a question, Shashank, but I would
Yeah.
suggest a break because all of a
Okay.
sudden this was a
Yes.
lot of information very quickly, and I do have questions perhaps when we come back from break.
Okay.
Okay. So let's take a break. Let's come back at how much more content do you have, Shashank?
I think we won't be able to cover part 2, so we'll just cover part 1 and then call it a day. I think.
Okay.
Because
So
I think the fellows have the notebook available, so then they
Yeah.
can run it on their own.
yeah, so let's come back in 10 minutes. So 12, 18.
Okay. Yeah.
All right, we can resume then.
Yeah.
So before we started, Shashank, I wanted to
Yeah.
ask,
Yeah.
and I think it's an important question, and maybe next time, maybe address it early on, but why would we do this? What is SQL for, and who would use this?
Okay, so I can tell you how I use this. So I work in a healthcare informatics lab where we have access to databases such as all of us, which has data over a million patients. And how I access all of us is using Google Cloud, which provides me with a Jupyter notebook. And it's a SQL database. So let's say I want to know, for example, let's say disease, let's say like traumatic brain injury, which I worked on before. And I want to know that what patients are there, what are their, let's say, demographics, where do they belong? And what happens in all of us is that their EHR, the electronic health record data, is pulled up with their demographic data. So I can look at, is there any discrepancy between patients belonging to a rural setting and an urban setting? What kind of diagnoses are being made? What's the most common type of traumatic brain injuries people are getting? So since this is a SQL database, I can connect to it using some of the tools and then export the data into pandas and then run my analysis. Yeah.
So essentially you have millions of data, millions of lines of data, and not only millions of lines, but also hundreds of columns.
Yes.
Which
So in all of us, like last time I checked, it was about, so if you cover everything, it's about like 500 million. So you cannot export it directly to CSV because then you're gonna die, like your PC or whatever Google Cloud is not sufficient. So the best way is that you write your queries in SQL, then export it to pandas and then run your analysis.
All right.
Yeah.
And thank you for explaining that.
Yeah.
And I wanted to also ask, what are the differences between, for example, Postgres SQL, SQL, or DuckDB?
Yes.
So
Yeah. So for Postgres or MySQL, the initial overhead is high that you need to install lots of softwares and stuff. But since DuckDB is good for like teaching yourself or teaching, like how I learned SQL is just like use a CSV and put it into a DuckDB database and then start writing SQL command just to make myself familiar with SQL. Because let's say to learn stuff, you initially like set up everything in MySQL or PostgreSQL and then run. So the initial overhead is high. Like probably we would have spent like 1 hour just setting up your MySQL. So
the database
instead,
itself.
without DuckDB, we chose like MySQL or something else.
Okay.
So
Yeah.
oh, I'll let Jeff go.
I was gonna say along that same lines, is DuckDB just supposed to be used in Python? Or
No,
can it be
so
used
yeah,
standalone
so
in other ways?
it's in standalone. What the Python, the pip package is to connect your notebooks with the databases, but the standard way is to run it on CLI, like the command line, because you have a because DuckDB works in in-memory. Like, you don't need like fancy setups. You just need to install that and run it through command line. So that's the standard way. But Python probably I chose because people are more familiar with Python running Jupyter notebooks.
Well, Shashank, thank you very much for the explanation. As somebody that doesn't use SQL, but kind of knows what they're used for, I think one of the more important things is why would I use this, you know?
Yeah.
So
Another example is Mimic 4, which I use. It's another medical information mart database. And it's like the standard, like the most commonly used open source database available right now, because not everyone can get access to, let's say, Banner and get their own data. So if you want to learn things, then you can get access to Mimic, but Mimic comes in SQL. So you need to learn SQL to do any kind of data analysis.
thank you very much for the explanation, Shashank.
Yeah. Okay, we can resume, I guess.
Let me ask some other questions.
Yeah.
Okay, so the patient data, medical records seems like kind of a
Yeah.
perfect example of what you're showing. What about other types of data? Like I work with remotely sensed imagery, let's say drone imagery or GIS data or something, and it's not just columns and rows of
Yes.
strings and numbers. It's huge array data.
Right.
Is that appropriate to put that kind of data in
SQL,
SQL?
maybe
Does that make sense?
No, I don't think so, because I think from what I've seen based on my experience, I think NoSQL databases are good, because then you can represent your images in like base 64 or something, so that you can quickly fetch, because right now what we have is all text and numbers. We don't have like unstandard data, let's say audio or video inside it. So I think for that, I think we need to move to some other kind of databases. Yeah. Maybe like Mongo, which I covered in like one of the data lab tutorials. That's good. Yeah, and I think like I just one more thing to add on Jeff's question, that I believe his like your spatial data set is like gigabytes of like hundreds of gigabytes. So I think SQL is not the way to go. I think Spark is better, like Apache Spark or PySpark is the better thing for data set. When you go above anything beyond like hundreds of gigabytes, then you need to look at like distributed databases.
So a lot of people are putting their GIS data in something called PostGIS, which is an extension for Postgres SQL. And I've never really used it, so I don't know exactly what it is, but it seems like it's an offshoot, it's connected to Postgres, but it's specifically for GIS
I think,
spatial
see,
data.
you can think of this as ease of use versus like, for example, like C++ and Python, right? Like things will run quickly in C++, but to learn C++, you need to put a lot of effort, versus like Python, you can still get started easily, but if you have a larger process, it will run slow because you are using an interpreter language. Same thing goes with SQL versus those databases which are used for terabytes. Like, you can set up things easily in SQL. It's good for the user, but things will run slow. But if you move on to more complex tools like Spark, the initial learning period may be high, but then you get the benefit later that once you develop those applications, they will run fast.
Any other questions from anyone else on here? Kind of bigger questions. Why use databases or anything else?
I guess just to add the comment that I've been using relational databases for a really long time, and yes, it has been mostly clinical data, but a lot of the relational part of it, I think, is where this has its strength, because you don't always want to look at all of your data all the time. So with something like SQL, you can pull apart data, reassemble it, and also you can look at one-to-many relationships, which is, I think, where the strength lies. So when I'm dealing with my data, I've got, multiple observations within, a participant or, participant or a patient. But I can also just pull most recent and aggregate those. So it's both like over time and over space. So that's what I think the strength of relational databases is. You can break them down and pull them back together any way you want.
Yeah, I think that's a great example because that's why probably I chose a clinical example here, because that's where I find SQL being used the most. Yeah, any other questions, anyone? Am I audible or am I stuck? Okay, I'm good. Okay. Okay, you can go back to where we were. We find that we were here. Yes. Yeah, so before the break, we were looking at aggregating data in from the observations table, and another is that, so we looked at the average heart rate, how to get the average heart rate per patient here. Next is we can look at the count of heart rate records. So instead of doing this round of and then casting of the string value, you can just count the number of records returned by the command where you're looking into the observations table, matching the description with the string identifier here, that whatever you find in the string, just return it. And then we were grouping those data by the patients and then counting them here. And that's how we find that we have different heart rate records, probably one record for each observation window, I think, here. Okay, next we can look at another table, which is the immunizations table. And why we are looking at, because we would like to aggregate data from all the 3 or 2 of the tables together next. So here, once we run this, we look at what kind of immunization was given to one patient and during which encounter, what was the code and description. And we can select some of the columns from this table and just to get an idea that what columns are available there. So yes. I think, yeah, oops. Okay, so it starts with the patient identifier, the encounter here, and the description tells you, okay, what kind of vaccine it is. So, and then we can see there is a unique code attached to this vaccine. Like, for example, 140 stands for like some flu vaccine given, then there's like hepatitis A, then you have different IPV vaccine, different vaccines available here in immunizations. And similar question we can ask here, what's the total cost of vaccinations per patient? And right now, instead of count, we are using the sum. So let's see how it works. Is we first go and tell the command, okay, look into your immunizations table and group the patients together. Once you group them, go look at the base cost, sum them together, all the base cost for all the immunizations for one single patient, name it as total cost. So this is the new column name for this sum operation. And based on that new column name, put them into a descending order. So once you run this, what it should return is the patient name, patient ID, and the total cost here. And probably you may think that this is like some random string here. So let's say if you want to find like, okay, which patient this string belong to, for that we need to do joins, which we'll look at in the next section. so that you can replace this string by the actual first name and last name of the patients and then get like the actual cost here. Okay. Yeah, next moving on to the topmost common vaccines administered. So these are like some of the common questions which can be queried from the immunizations table. So here you can look at immunization in the immunizations table. First, you want to group them based on the description. Since this description is kind of unique, attached to one unique ID, which is this 140, where we see that each ID number here belongs to one uh, unique description for one vaccine. What we can do is uh, extract all those description and then do a count here, and based on that count, put it into a descending order, and then just limit it to 10 because we just want to see the top 10 most common vaccines. And we see that, okay, this flu vaccine was the most common vaccine administered for all the patients. Okay, and like I was saying, we need to look at joins here. So what are joins? Joins are very just like a very simple way of combining data from two rows or two tables or more. And it's also possible that you can do join on the same table itself. We'll look at the example in the next cell. Yeah, there are several types of joins which and they serve different purpose. So for example, let's go through this figure that you have table A and table B. So inner join means that you want to look at all the rows which appear or all the IDs or are those tables. And you think of join as like what happens in set theory, that you have two sets and you can define two operations which are intersection and union. So inner join is an intersection operation that given two sets or two tables, you want to know what rows are common between those two tables. That's inner join. Left join is that you want to know all those rows which appear in left join along with all those rows which are common between your table A and table B. And this will get more clear once we look at the example. Same with right join is just the other way around, that instead of table A, we are looking at table B. And here in right join, what we have is the common elements as well as all those rows appearing in table B. Full join is just everything together, that you have row all the rows appearing in table A, all the rows appearing in table B put together. Self join is when these two tables are the same, then you can define like a self join. Just want to find the commonality between one single table. And cross join is, I mean, it's called a join, but it's just like a multiplication operation, that given all the rows in table A and all the rows in column B, what possible uh, you can say it's like uh, what possible combinations are available for rows appearing in uh, table A versus table B. Okay, and for all the next examples, uh, let's assume that your left table here is your patient's table, and on the right you have the immunizations table. And first is the inner join, like we discussed that this join returns rows when there is at least one match between both tables. And if there is no match, the rows are not returned, which means that, okay, if it finds some common rows between these two tables, it will return it. If not, then it will just skip it. Okay. And like the example we discussed, that initially we were having all these vaccines or everything together appearing, but just like one patient ID. But now we would like to replace this by the patient's first name and last name. And because these IDs, the patient IDs are present in the patient's table, we can do a join on the patient's table and the immunizations table. So the question for inner join is that what medical treatments have been administered to patients, including the patient name and cost of each treatment. So let's go into this join command and let's see how it works. And it's again, this starts first with the table names that now you're saying, okay, from immunizations. So now you have table 2 here. You're doing an inner join, because in inner join, there is no like left or right, because you have 2 tables and you just want to find the common rows. So you're saying here that from immunizations, do an inner join with patients. And so now you mentioned that, okay, you would like to do an inner join, but on what columns? So then this argument comes that on tells us that you would like to do a inner join on these two tables, and you want to do the join on wherever you have this patient ID. So for immunizations, the column name was patient here. And in the patients table, it was known as ID. So right now what you're doing is wherever you find these two matching patient IDs and immunizations in patient table, you would like to join that. So once you have this result, now it's returned to the first part, that once you have the join result, what column you want to extract. So from the patients table, once you have the join result, you would like to extract the first name, last name from the patient's table, and from the immunizations table, you want to extract the description of that vaccine or immunization and the base cost here. So once you have mentioned this, and what you can do is order by, like what we saw in the order by example, we can order by this result based on column patient's first name and put it into ascending order. And once we run this, we'll see that instead of the random IDs which we're getting above here, we have patient's first name, last name sorted by the patient's first name, like for the all the errands are together. And then you have the description of the vaccine and the base cost here. So any questions before we move on to the next one?
Yeah, Shashank,
Yeah,
broader question.
yes.
So the joins is the joins about creating a new table, or is it
Yes.
simply about
It's not a table, I would say it's just
Not a
a
table.
result stored into a
it's
memory.
still a selecting process,
Yes.
only we're selecting from multiple tables and not
Yes.
just from one.
Yes.
Okay, but we're not creating a new table.
Yes. So
Okay.
there's another way, it's an advanced function, it's called the view. So what it does is that once you have a new table, uh, like for example, let's say you have a query which you want to run again and again, and it might take a lot of time to run that. So what the best way is that you run it once and then make a new table. So it's called a view inside the C. It's called a SQL. It's called a view. So you can save that into the same database and then query it, so that you're not doing the same process over and over again. So for example, let's say this table, let's say we had like, let's say millions of patients and all the vaccines. So it might take, let's say hours and hours to run this. But if let's say you are using this information at several different places, so the ideal way is that you run it once and then save it into the same database, so that you can just query it next time you want to use this information. Yeah, because I don't have any like a variable here which saves this result into like a variable name. So this is all into memory right now. I hope that answers the question. Yeah. Okay, next we can go to left join here. And what left join, like we discussed, that it will give you all the rows in the left table as well as whatever matches to the right table. So, and then for all the examples, again, we have the left table as patients and then right table is immunization. So what it would return, what question we can ask here is that for all patients, what are the treatments they have received here? So just would like to like, so for all patients, it's in the name, in the question itself, like you're looking at all patient, which means that you need to do a left join, that for all the patients, you're not looking at what are the common patients like what we did in the previous example. You're looking at all the patients and what treatments have they received, if any, which means that whatever you have in common with the immunization status on it. So for example, you have, and how it works is that we go back to all, that's the start of all the SQL queries that you first would like to mention from patients. And see, the order is changed here because in previous one, since we were doing a inner join, there is no concept of like a left and right. So we wrote immunizations first and then patient was second. But in left to right join, the order matters. So that's why we have the left table first. So we are telling from patients, which is the left table, do a left join on immunization, and ID to use is your patient ID, which is an ID from the left table. It should match with the patient's ID in the immunizations table. Whatever result you have, you extract all those four, or not four, but you will get many attributes like all the combinations, but would like to have all the four attributes together, the first name, last name, description, and base cost. And then you would like to order them based on the first name of the patients here. Yeah, and this is how I think, and the difference is that since what it does like a left join, so we still have like one null here because for this patient it didn't find anything, but since it was a left join, it was supposed to return all the IDs together. So this is like one way you can see that although for this person it didn't find anything in the immunizations table, but it still returned this row because we were doing a join. Yeah, same goes with another patient, is Antonia, because for these two patients, it didn't find anything into the immunization table. But since we did a left join, it returned this null. Okay, can we move to the next question? Questions? Okay, I can move to the next example, which is right join. And here, like we discussed that our immunizations table is our right table and patients is our left table. So this returns all the rows from the right table and the matched rows from the left table. And the result is null from the left side if there is no match. Similarly, what we had in they say that the result is null if from the right side if there is no match. So in the right join, the result would be null if there is nothing returned from the left table. And the questions that match and show all immunizations. And the question is in detail is for all immunizations recorded, which patients received them if identifiable? So what we are asking, like here, given all the immunizations, what is the list of patients together? So here the result is very big, but it just gives us the results in sorted order that now we are ordering by on patient description. So for DTaP, this vaccine, it just gives like for all the patients here, who received this DTaP vaccine. Yeah, next is full or outer join or full join. And it tells us that it just gives you a comprehensive match that this returns rows when there is one match in one of the tables. This combines the result of left join and right join. So if you put these two tables together, you should be able to get this table. And the question you can ask is, what is the complete list of patient and their immunizations, including those without recorded treatments or identifiable patients? So you can either have null in the description or either have null in the patient name. The full outer join is just putting left join and right join together. Okay, next is cross join is the, like what I was saying, that it's just the multiplication of all these terms. So it's defined as a Cartesian product of the two tables, which even if it's not there, it will just combine everything together. So for example, and this might give you like weird result because sometimes it may not make sense because this person, Tammy, might not have got all the vaccines, but since we are doing a cross join, so just putting together things. So in most of the cases, doing a cross join might not uh, lead to like any meaningful result. This is just for like demonstration that there is a function called as cross join, which you can do on tables consulting like patients and immunizations. It will just give you like for example, you have, let's say, 10 elements in table A, 20 elements in table B. So by cross join, even if there is no match, it will give you like 200 elements. It will just put them together. Okay. You can go to self join. It's not a different type of join, it's just like a regular join, but it's based on the queries in the same table. So one question you can ask is which pair of patients are from the same city, uh, if you are curious to know. So what you can do is do a join here. So it's not a join, it's just putting together things here, that wherever you find that if they have the same city, just print them together, because there is no join function here. But we would like to just compare rows compare rows in the same table, and it returns that okay, all these patients are, since we are sorting it on the city name, it's just telling it that okay, all these patients belong to this city. And same aggregate function are slower, so there might be like a different way to do this kind of thing. Okay, there are some more examples of join. Okay, yeah, how much time are we
Shashank,
left with?
we do have 10 minutes, but
Yeah,
since the fellows do have access to this notebook, maybe we don't need to go through all of
okay,
the join examples unless
yeah.
there is something specific that you want to point out.
No, there's only one more example. It's like join is not just for two tables, you can extend it to three tables as well. So
Okay.
I've included one example where what we do is do a join on the patient's immunizations and lab results table. And this is useful for like asking complex questions like, for all those patients who received an influenza vaccine, what were their lab result on cholesterol? So I don't know, this question makes sense medically, but there could be like any example you can ask him. Then you can have like do multiple joins, like you can treat table, patient's table at the left and immunization on the right, do join first here, then use that result to do a join on observations table. And once you get the result, that the first name, last name, vaccination, and these are the results for the patients on the cholesterol test. So that's an extension of the join to three tables. Yeah.
Well, thank you very much, Shashank. I have a question, which
Yes.
is going back to something that you stated earlier, which is okay, cool. So now we have tables, but how do I import these tables in, for example, pandas?
Okay, yes. So for that, yeah, I was going to cover in the next part. It's there. So there are two ways to do that. The first one is DuckDB provides a function where you can link your DuckDBs and export it to pandas.
Mm.
The other way, which I have provided, it's in the next table. It says exporting data from C to CSV from SQL.
Cool. Okay.
Yeah, so once you run this, what it will do is, so if you like, if the fellows want to learn this, they can go through the next tutorial or the next notebook. So where I have this example that I I can just briefly summarize that here we put, here we start from an empty database, put data into the database, and then export it to CSV and then load it into pandas.
Yeah, this sounds incredibly useful, actually.
Yeah. Because I'm not sure if we can connect, let's say, matplotlib to SQL or something to visualize things. So we need to have at least like some way to connect SQL, export it to, let's say, a data frame, and then use it to visualize things.
Yeah, something like a middleman.
Yes.
Well, understandable.
So
Well, Shashank, thank you
yeah,
very much.
yeah. Just
Do you
one
have
last,
anything else
yeah,
to add?
last
Yes.
thing is that you may wonder that how did I, one sec, how did I created this? How do I got something.duckdb, which is 700 MBs of different tables? So the secret to this is that there is a way. What you can do is initially this COVID-19 database comes as 16 CSV files. So if you don't know any SQL, that the right way is that you load all the CSV files into pandas using like read CSV, write it multiple times, and do it. The another way is that I provided a function. What it does is that it goes through all the CSV files into your folder and puts them into like just like a read the CSV, dump it into DuckDB, and then you can have your own database. So this function tells us that reading CSV and importing data, which means that okay, you read all the CSVs using this globe library, which is it just gives you like what files are present in the folder, and you read them into pandas. Here I'm using pd.read CSV, put a table name, and then what I do is create a new table and insert all the data into that table. Yeah, so this is the way, let's say you have lots of CSV to compile it to one database and to run SQL queries, then this should be useful. Yeah, that's it, I guess. That's the useful part from tutorial 2.
Well, your time is very much appreciated. Oh yeah, Jeff's got a question. Go,
Yes.
Jeff.
I didn't quite get the last part where you're talking about pandas and making the tables out of a CSV.
Yeah, so I can tell you
Excuse
how.
my
Yeah,
ignorance.
no, it's okay. Yeah. So I guess this thing started with like Nirav mentioning that we should have a DuckDB tutorial, but I looked so hard I couldn't find like one open source DuckDB file anywhere. So how do I make a tutorial then if there is no DuckDB file I can download? So that's why what I did is I took a bunch of CSVs, converted them into a DuckDB database, and then said that given this DuckDB database, how do you run queries on them?
Okay.
Yeah.
Could you use the DuckDB Python library to make?
Yes, that's
DuckDB
what I have here.
files?
That
Okay.
since we let's just see it quickly, maybe like two more minutes. So here again, I have this import DuckDB here.
Yeah.
How do you import the library? Then once just we can go quickly back to here that now what I do is this, that I say DuckDB connect to library.duckdb. So what this will do is create an empty database, name it library.duckdb, and make a connection. And then what I can do is read CSV files one by one, read their data and dump it into this DuckDB database.
Okay. And then once things are in DuckDB, it becomes easier to query everything using
Yes.
SQL language, as
Yes.
opposed to, let's say you had 13 CSV files in pandas.
Yes.
Is that hard to query things in pandas?
I think your management overload will increase. That how would you just keep track of all the variables you would create using pd.read CSV? Because
Okay,
to
yeah.
read 16 files, you need to have like 16 variables and then you have load each one of
Yeah.
the CSV files into
Yeah,
each, and
and,
then
and
keep
doing it in
doing.
SQL is much
Yes.
simpler.
Yes,
Putting
just-
everything, yeah.
Yeah, just put everything into one DB, and you
Yeah.
can play around with the table names if you want to query multiple tables.
Thank you.
Yeah, so this is again one example where your initial overhead is high, but then it will solve your later steps. Is there any question in the chat? Okay, yeah. I didn't know Carlos was in. Okay. How to connect Python SQL? Yes.
Well, it's 12:58.
Yeah.
And with 2 minutes to go, I believe we can call it a day.
Sure.
Shashank, thank you very much for your time. And
Yeah, last thing is that like I'm in the UFA data DSF channel. So if you have any questions, just ask me there, because I believe all the DSF fellows are there in that UFA DSI group on Slack. So
yeah, that goes for all of us. So
Yeah.
Jeff is there, I'm there, Carlos is there, and we can cover a number of topics on it.
yeah, anything related to like managing data and what's the best way to do things. Yeah, I'm happy to answer. Yeah.
Rudy, any closing comments?
No, that's awesome. Shashank, I mean, and DSF fellows, I mean, or data science fellows, as you can see, Shashank being a fellow a couple semesters ago, here he is teaching. It's awesome. So it's something that I would love to bring you all back one day to teach something to the fellows that are going through, or we'll see. We'll see how the funding goes. As you guys know, the current situation. So, but right now it's looking promising that we're gonna continue with DSF.